If you're a beginner or considering purchasing a thread for your simulation needs, then it might be a good help for the decision. This little tutorial. I've had another video previously. When I was a kind of a beginner with the program. Since then, I've done hundreds of hours of simulation in Thread, and also a introductory tutorial training with CBS Europe. So maybe I can give you this time a better overview what you can do in Thread. So if you open Thread, this is the dashboard, the main screen, where you start your activities. You can create a new document here, which will pop up like a screen like this. This is the main window in Thread. In the middle, there will be the 3D model and all the rays visible later when we have a model. On the left, there is like an object tree with sources. So what you need for the optical model, a light source, some geometry, lenses, baffles, optomechanics, and so on. Analyzes surfaces. These are basically the detectors. Let's call them detectors for now. If you are familiar with Zemax Optics Studio, then here will be like the surfaces where you analyze the intensity, distribution, illuminance, and so on. And then there are of course materials, which there are a few basic materials in here. This is basically what you can choose at the beginning from, but you can add new materials. There's a material catalogs available for your geometry. So you can add coatings, you can define here the radius properties. If you have some scattering surfaces, then you can add your scatters, surface roughness, or spectra if you want to simulate something with continuous spectra. Keywords, scripts, these will help kind of to handle the model. And scripts, it's something like macros for Zemax. And there will be analysis results, which where you can store your detector results, the results from your detectors. So that's the main object tree here on the left, the main window in the middle, and there on the right. I thought previously that this window is not really useful, but it is kind of very useful because all the results, the summaries of the ray trace, the summaries of the detectors, and errors, warnings, they will be all displayed in here. So useful. You can also replace them. So you can put this window to the bottom. You can rearrange these things here. I found that this arrangement is probably the best here. And then so what else you have? You can open here multiple files. So there will be here multiple tabs. So if I open here a new new script or a new thread document, it will put it in tabs. I don't really know how many documents are possible, but it's quite a bit. Let's just stick to one for now. Then at the bottom there is like the coordinates of your mouse pointer displayed in the geometry, and a few informational things. And there's this stop button here, which is useful if you want to stop the simulation, for instance, the ray trace itself. So there's also toolbars here at the top. You can move these and replace them. You can make them float and so on. There is actually more toolbars than these, but I'm not using all of them, so it's just the ones which I found useful. Yeah, and there's of course menus where you can do analysis, you can do the optimization, setup, ray trace, tools, and so on. The most of these you can also, yeah, a lot of these you can do just by right-clicking stuff, yeah, like adding geometries, positioning, and so on. Yeah. It's getting a little bit messy, so I would say we start it's somewhere like with the object, so like a basic simulation model, what we'll do here. So optical sources, yeah, if you right click this folder, there's like a lot of menus in here, where you can set up the optical sources. Here you can create sources. There's a few sources here built in, coherent or incoherent sources, but you can that's just like basic type of things. You can also add like more detailed optical sources like arrays. You can define exactly which angle and which detailed properties the source should have. Yeah, so let's just go on and add like a primitive source. Yeah, we can add a Lambertian plane, for instance. This will be just like a plane. Yeah, you can select if you want it circle or a rectangle. Let's just stick to the circle. 1 watts of power or lumens. You can choose the lumens. Let's just stick to 1 watts. You can say how many starting ray positions should be. So this is basically a plane with, there will be 42 rays coming out of this plane. We can change it. Let's make it 500 for now. So just we can see a bit more. Number of random directions per ray, self-explanatory, and then the size of the of this plane. So let's say we want to have something that's as default as 1 millimeter. So let's make it, I don't know, 5 millimeters times 5 millimeter semi-aperture. So it will be a 10 millimeters times 10 millimeters diameter circle. And the spread, we should probably add something smaller, let's say 10 degrees. So it's not going everywhere, but a little bit directional, this thing. And then that's all the geometry. You can choose polarized if you want polarized, but maybe we'll come back to it later in a different video. And then you can choose the wavelength. So for the wavelength, if you just have like a single wavelength length source, I usually use the neodymium laser wavelength, but there's like a couple of standard wavelengths what you can choose from, or you can just enter manually whatever wavelengths you want to use. But if you want to use like a list, like a few more wavelengths, you just choose list, and you can add here a couple more wavelengths, and you can choose color of the different wavelengths separately. There's a really handy option here. If you again right click, there's a lot of right click menus everywhere. So like I said, the colors, just pan from blue to red, or according to the appearance, visual appearance of the color of the wavelength. Yeah, for now we will just go with the single wavelength. Yeah, but what I haven't said, that you can also choose a spectrum. So like according to spectrum, you can add in the spectra folder a continuous spectrum, and yeah, it will randomly choose in this range from the spectra with a given probability a ray. So for now, okay, let's just make it like about green. Yeah, So select it also, the ray should be green, and you just click OK or apply. If you just click apply, yeah, it will create the source. With OK, it will also close it. It's when it's created, it's often good practice just to go click view all, so you can see the source here. Sometimes you don't see where it is, or it's like a bit distorted, this geometry, so just click view all. You can see the starting rays there in this little box. To see the actual rays, we will have to do ray trace, but there's actually nothing else in there, so we will have to add some kind of geometry. I would say we add a lens in the geometry, and it's again right click, and there is, for instance, a new lens. What you can add here, by adding a lens, of course you can add a semi-diameter. Yeah, let's say it will be a 50 millimeter diameter, so 25 radius lens, 5 millimeters thickness, and you can choose to add a radius, back and front radius, or just choose like a focal length. I would say we will choose a 50 millimeter focal length, 50 millimeter diameter lens. Yeah, thickness, the 5 millimeter might not be enough. Let's have a look. Right, it's a bit distorted, like I said, and it's definitely not enough. Let's make it a bit longer, 100 maybe. Ooh, okay, still not good. Maybe a bit thicker, 8. Oh yeah, nice. Right, so it's now the curvature is distributed on both sides, but you want to have like a planar convex lens, then you can choose the bending parameter to be 1, yeah, or -1 if you want to have it bent the other way around. Yeah, so this is how you do lens. Very easy. Shifting the lens, of course. So you can see it in the geometry folder. You can open these items in there. If you click on the lens, right click again, and click position orientation, then you can set up where it is. Every object has its coordinate system and orientation and so on. So it's now basically the geometry folder, the 0 position is their starting coordinate system. I can go here, right click and append, and I can shift it, rotate it, yeah, whichever operation you prefer. We'll just shift it in Z direction by let's say, what was it, 100 millimeter focal length lens. So yeah, it's shifted. Now if I go again, view all, then I can see it there. Just a little source, and there's our lens. Right. Now, okay, so I will just close this here. Now, if you want to see the rays, yeah, there is like a ray trace option here. I have it in the quick menu. There is like just tracing the rays. Yeah, I get immediately some kind of evaluation here. But apart so like in the main screen, nothing happened. If I want to have like also render, so visualize all these rays, I have to click trace and render. But there's a few things which we haven't set up yet, really, with this lens, which we have to do for every object, really. And that's what material it's made of. So if you want to have a material, you can just, simple glass. I think it starts as a simple glass anyway. Yeah, you can just pull the material on it and click OK. There is like other materials here. You can add a glass catalog material. Yeah, so there's like a lot of different glass manufacturers, and from Schott, for instance, there's a lot of different materials which you can choose from. It's pretty basic in optical simulation software, I would say. Yeah, so you have to choose the material for this lens. and you have to give it like a coating. Coating should be transmitting coating. It's there's a little description here for all these things, which you can also edit if you double click on it. Yeah, we won't do that now, but yeah, so that's 100% transmitting coating. So all the surfaces will just transmit without Fresnel reflection, or you know, it will just 100% transmit all the surfaces. You can define the different properties to the different surfaces if you want to. So if I want, I don't know, this surface to reflect, this one to transmit, yeah, okay, then I can define it separately, but I want just both of them to transmit. And then one more thing which is important to define is the ray trace properties. So you have to tell the program what you want to consider with this object. So the lens, you know, if you have like a surface which partially reflecting and partially transmitting, then you can say, okay, I want to have both. So allow all, or I just want to see what does it transmit. So I will just put this transmit on it. And yeah, I think lenses come already with this kind of thing. The ray trace properties are set up at the beginning, but yeah, if you have a new object, it's like always default. You define a material, a coating, and a ray trace property for it. Now, okay, so now we have our arrays, and we want to evaluate somehow. You know, what's the distribution, let's say, the collimated beam from this surface and with this lens behind the lens. For that, we will have to define here plane and put an analysis surface on it. To do that, I will add here in the geometry, again, right click, add a new primitive element, and there's like a lot of things you can add here. You know, we previously added a lens. But yeah, so there's like spheres, ellipsoids, cubes, blocks, rods, pipes. Yeah, so there's like a lot of things. You can also construct very easily your own 3D objects. Yeah, but I found that in most cases, 95%, 99% of the cases, these basic primitive elements will just do. So for the detector, we will choose a plane. Yeah. And this plane should be, yeah, so at least, let's say 25 semi diameter. We have a 50 lens there. It should be rectangular. I can also choose to be a circular thing, but detectors are traditionally kind of rectangular. So, and if you want to, you can also define like a hole in the middle. But yeah, we will just go with this normal rectangular plane. Right, you can add here immediately what it should do. Yeah, so it should absorb. That's good. That's what we want. It should, yeah, made of air. That's okay. And it should be at, let's say, distance of where we had our lens at 100. So let's put this 150. Huh? Right. So if I click apply, and I can immediately see the surface here. And it holds the rays, so works good. To make it a detector, we will have to add here a analysis surface and attach to it. So if I close these, just to have a bit of order here, I will have to add here an analysis surface, new analysis surface, and it doesn't really matter what the size of it for now, so I will just click OK. 21 times 21 pixels. Maybe let's make this a bit larger. 51 times 51. And now we have our analysis surface. We will have to put it on this plane. To do that, we'll have to right-click this and attach analysis entity, and you can choose from the list this plane. So this plane has a where is it? The plane surface. It has a plane surface, which I will select, and now you can see that our analysis surface is on it. It looks small actually. Yeah, we could make it larger, but if you leave the auto size the data, it will mean that it will auto size it for you for the beam when you evaluate it. Actually, why not? We can put the size to the whole size of this plane. Yeah. So what I did now is I just added 25 sometimes 25 size for it. Right. So that's basically it. Now we have this Lambertian plane. Yeah. Emitting the light, the lens, kind of collimating the light mostly, and then the plane detector. If we do a ray trace, then we will have to remember that it's only a small number of rays, so we have 500 rays here. It's probably not going to be enough. So if I just go like analysis, there's a, yeah, we should probably do a little bit more. Wait a minute, so let's say 50,000, 500,000 rays. Should be okay. Oh, yeah, okay. Maybe let's just do the calculation without rendering. Actually, we can render it. Yeah, why not? So that was a little calculation going on, but it's all done. 500,000 rays. So analyzing the results is found on the analysis tab here, and there's like a lot of options here. Maybe in some other episodes we can come back to it and have a look what all these do. But for now we will just choose this irradiance spread function, and you can choose that there's this analysis surface, which surface you want to evaluate, and this is the analysis one. Yeah, just click OK, and I will get the distribution or the beam on the detector. So what I find really cool, but maybe not that useful, you can do like a perspective view here, which, yeah, looks a little bit better. It's you can do cross sections, and the cross sections of the distributions will be shown on the right. You can do like a lot of transformations. You can customize all these things from background, style and so on. You can scale the data, smooth the data. For instance, smoothing is now something which would be probably useful. Yeah, you see, smoothed it by averaging one point there, every column and row. So just go back to this view. Yeah. This is something useful. You can analyze the data here. If you want to, you can also put this kind of view in the 3D view. So visualize it. So right click, and there's again a lot of menus showing visualization view. We'll just click OK. We'll probably draw it there. Yeah. Yeah, it's often if the surface is the plane itself is not transparent, you get this kind of effects here with the drawing. So if you right click on this plane, the actual plane we had there, and click visualization attributes, you can make this invisible, and then this kind of effects will disappear. Yeah, so that's what it is. A really basic model. This is how Fred works. Yeah, you just define your sources, you add your geometry, you define your materials, coatings, and what you want to trace. And here we go. We have a model. Of course, it will take much more time if you work with a more complicated model. But this is basically the process of building these simulations. there's maybe a couple of more things which we can in this introduction video we can go through here. These menus. You can there's this file menu where there's you can print the view. You can save this image as it is. You can get your previous files opened. You can save or save as your work here. There's undo. It's showing that I set up 5 steps which I can undo. It's usually yeah, I have to say it doesn't work very well. It does work actually. It's just every time you click undo, it will just close all these windows, and it's just like a fresh start. It's I don't know. I don't really like clicking undo. I have to say that, but yeah, you can do that. You can copy paste objects here. If you're there already, you can Control C, Control V. Yeah, you have now 2 planes. Yeah, you can copy paste objects, not just inside within one model, but between models. You can import optical models from different software. Optic Studio, Code V, Oslo, and so on. Unfortunately, Optic Studio models can be only imported if they are sequential. Non-sequential models don't work. CAD parts you can import, and you can also export these your components as step files, for instance. There's quite a bit of options for view options, just really the style of the windows. Then there is a few toolbars and things. Yeah, it's something you set up once and don't touch it later. There's a lot of tools here. What's useful here is the reports or the preferences. You can set up basic visualizations, ray buffer. That's something what you have to do at the very beginning when you first set up your program. Yeah, just a few options here. What is worth going through. Maybe we'll have a look at it in a different video. But yeah, that's something what you would set up at the very beginning. Then there is ray tracing. So there's a lot of type of ray tracing. Advanced ray trace is very useful, where you can basically create a ray path, ray file, database with all these rays stored, and you can analyze this path, ray path later. For instance, if you're interested for stray light. Then there is a few things here for the 3D view. Yeah, you can do a movie. Okay, interesting. I haven't used that before. But the view is basically these kind of controls here. You can select different view directions. Yeah, the model. There's a few basic views here also built in. Yeah, then there is what else is there? Oh no, I did the ray trace. Okay, it's done already. You can create objects, so that's basically things which you can access also with right click to the different folders. We can do sub-assemblies. So for instance, in geometry, if you do a new sub-assembly, you can pack some things in there, like these are the lenses, but you can then or the planes. You can put a new sub-assembly for the lenses. That's useful. Yeah, what else? The analyzes. So we checked the irradiance spread function, but I find also the color image useful, especially if you have LED illumination. There is yeah, there's like a lot of functions here. Maybe sometime next time we can talk about these. There's the MPC menu, which is the highest version of Fred. If you are in luck and you had the funds to purchase this, then you can trace with extra high speed race using the GPU. Otherwise, Fred is only using the CPU. Only one thread if you do trace and render, and all of the available threads which you set up in the preferences, and it's using all of the threads of the CPU. Yeah, then there is the optimize menu, which is available only with the MPC or the Optimum version of Fred. I find this really useful. You can define parameter pickups, configurations, and you can optimize your model by defining variables. Yeah, with minimum. Oh wait, let's make this a bit larger with a lower upper limit, step, and you know what you want to do with it. Yeah, there's a lot of parameters here which you can really easily, really quickly set up if you want to set up a optimization. So variables and of course the merit functions. So like spot radius, total power on the detector. Yeah, there's a lot of options. Yeah, and you can of course add as many options as you want. There's like different methods, optimization methods, and I guess I never used this board before. I think you can store here the results of your optimization, the different outcomes, and then yeah, so there is the windows which you can close all windows, for instance, here. Yeah, basic. And there's the help. There's like a really extended help, like a lot of tutorials built in. There is like a lot of help topics for scripting, for instance, or you know, basics. Everything is nicely described here, how to use these, and with examples. So if you're lost, you can always refer to this this help topics there. Yeah, so I would say that's it. So for today, a little introduction for Fred. If you're a beginner with Fred or interested purchasing it, I recommend you to purchase also a tutorial, like an introductory tutorial, with photon engineering or CBS, because it's very useful to start working with the program. Maybe it's even more useful if you already did some kind of models and did the first steps already yourself, and it's just the tutorial, the introductory tutorial training would be like a confirmation or like a advancement of your skills with the program. So I recommend you to take that as well if you purchase Fred. And yeah, thank you for listening, and see you next time.